Welcome to 3.7, Part 2, Graphing and Writing Rational Functions. So, what we will do is we'll review how to graph a rational function. Notice there are 8 steps, a lot of steps, but let's get into it. So we're going to graph a rational function. So the first thing that we need to do is we need to find the y-intercepts. So those are going to help us. We need to find, we'll factor it. We need to find any asymptotes. We need to find both vertical, horizontal, and slant asymptotes. We will need to find the x-intercepts as well. And then we will probably need to evaluate some function, some points of our function to determine which side of the axis it is on. So let's start. All right. So this is number 8. So we were given the function f of x equals x plus 2 squared x minus 2 over 2 x minus 1 squared x minus 3. So the first thing we're going to do is we're going to find the y-intercepts. So we are going to set x equal to 0 because a y-intercept occurs when x equals 0. So we're going to have 0 plus 2 squared, 0 minus 2 squared, times divided by 2 times 0 minus 1 squared, and 0 minus 3. Now let's evaluate this. So we're going to have 0 plus 2 is 2, so that's 2 squared is 4. 0 minus 2 is a negative 2. Oh, and we are not going to square that. So that's just going to be times negative 2. Here we're going to have 2 times negative 1 squared is just 1. And 0 minus 3 is just negative 3. So we are going to have... So I'm going to go ahead and take out these negatives and make them just negative 1s so that I can express things positively. Okay, so notice I can cancel these negative 1s out. I can cancel these 2s out. I get 4 over 3. So my y-intercept is 0, 4/3. Now the second thing I need to do is factor it, but notice this has already been done. So our third one is we need to find the x-intercepts, and that is, we're going to look at it, and whatever factors are not shared with the denominator, we're going to take those. So notice that we have x minus 1 in the denominator and x minus 3 in the denominator. Neither of those is in the numerator, so that means I can just take the entire numerator and set that equal to 0. Which means I can now take both of these factors, I can ignore the square, and I can set these equal to 0. So that gives me x equals negative 2 and x equals 2. So my x-intercepts are negative 2, 0, and 2, 0. Because remember, an x-intercept has a y of 0. Now our fourth one. So let's just see what number 4 is. We need to determine the multiplicities of the roots. Okay. So notice that x plus 2 has a multiplicity of 2, and x minus 1 also has a multiplicity of 2. X minus 2 has a multiplicity of 1, and x minus 3 has a multiplicity of 1 as well. And we're just going to make note of those because those will come in later. So now we're going to work on vertical asymptotes. So that is anything in the bottom of our rational function that is not a common factor with the top. So remember, if it's a common factor and it can cancel out, we will need to note that as a removable discontinuity, but we don't have one. So our factors on the bottom are going to be x minus 1 and x minus 3. And we set those equal to 0 because when those are equal to 0, our function will have an asymptote because we will be dividing by 0. So these are vertical asymptotes, and they will have the form of x equals some number. So here we have x equals 1 and we have x equals 3. And those are vertical asymptotes. Now notice that the next one is a removable discontinuity. So we don't actually have any removable discontinuities, and that is because we do not have any factors in our original that would cancel out. Sometimes you will, and you'll just have to make note of those. So a removable discontinuity, we don't have any. That is 6. Now we need to move on to 7. 7 is we have to determine a horizontal or a slant asymptote. So remember, when the top power is equal to the bottom power, we will have a horizontal asymptote with that is the ratio of the coefficients. If we have the top power is bigger than the bottom power, then there is no horizontal asymptote. But if the top power is less than the bottom power, we will have a horizontal asymptote at y equals 0. So while we don't have a horizontal asymptote when the top is bigger, we can divide, which will give us a slant asymptote. So let's evaluate these. And this is usually easiest to see in when you have it like multiplied out and not factored. There we go. So if we have got x plus 2 squared x minus 2 over 2 x minus 1 squared x minus 3. So here's the deal. You can either multiply this all out, which is totally fine, but it might take some time, or you could maybe use properties of like exponents. So since I only need to look at the first term, I really only care about my first term. So notice that x plus 2 is squared. So that means that my first term will be something like x squared plus blah, 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 blah times x minus 2. And this is just because it is squared. So the highest power x will not be any higher than whatever that exponent is. Remember that. So for on the bottom, I get 2 times x squared plus blah, 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 blah. It doesn't really matter. X minus 3. So now I could keep analyzing just the first terms. And notice on top, I'm going to get x cubed plus blah, 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 whatever. And on the bottom, I will get 2 times x cubed plus blah, 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 blah. Doesn't matter. So now I will have x cubed plus something over 2x cubed plus, I don't know, something. So this means that for our horizontal asymptote, our powers are the same. So it is just going to be the ratio of these coefficients. And remember, when you don't see one, there is actually a 1 there. So it will be 1 over 2. And therefore, we will get y equals half as an asymptote. Okay, now I'm going to zoom out. And we are going to have a look at how to graph this. So I will do this with some black ink here. There we go. Okay, so the first thing I'm going to do is I am going to look at my, am I still recording? Yes, I'm still recording. Good. Told me I was paused. So I'm going to look at my y-intercept. And that is going to occur at, let me label this. So I will have 1, and then I will have 2, and then I will have 3, and so forth and so forth. I will have 1, and then I will have 2, and then I will have 3, 4, -1, and then -2, and so forth and so forth. We'll give it a -3. There we go. Okay, and for continuity, I'll just go ahead and do those. So we're going to need to plot 0 4/3. So 4/3 is 1 1/3. So that is going to be approximately 1 1/3. That's going to be right here. And that's my closest approximation for that. So the next thing I'm going to need to do is I'm going to need to plot the x-intercepts. And my x-intercepts are going to be -2, 0, so right here, and 2, 0, right here. So now I'm going to go ahead and plot my vertical asymptotes, because those have also got to get done. And I will do that in red. So I have a vertical means up and down. So I'm going to have a vertical line, which is the asymptote, at x equals +1. There we go. And then I will have another vertical asymptote at x equals 3. Okay. So the next thing I will have a look at is I will plot my horizontal asymptote at y equals half. All right. And it is important to note that sometimes parts of a function can cross a horizontal asymptote, but they will not cross the vertical asymptote. So now I'm going to have a look at my roots. So my roots on the top, my intercepts, were x plus 2 and then x minus 2. So when x is -2, notice that our multiplicity was 2. So that means it's going to bounce off. At x minus 2, notice that it is going to cross. Okay. So I am going to try to determine to plot a couple of points. So I have f of x equals x plus 2 squared, x minus 2 over 2x, oh, it was x minus 1, x minus 3, is that right? Yes, x minus 1, x minus 3. So I'm going to pick a point. I'm going to figure out what's going on in this interval between these asymptotes. So I know that when my root x equals 2, I know that it has odd multiplicity because it's just 1. So it should cross. So I am going to see what is on one side of that and then what is on the other. So I'm going to get, here we are, 1.5 plus 2 squared, 1.5 minus 2, divided by 2 times 1.5 minus 1 squared, and 1.5 minus 3. Now, for the purposes of these types of functions, I just want you to get the basic concept, so it's not going to be so important to me that you find out the exact value. We can analyze the sign here, which is what we're going to do. So notice that 1.5 plus 2 equals a positive number, so we're going to have a positive number squared. Notice that 1.5 minus 2 gives us a negative number. We don't worry about the 2 because it's positive, so no matter what it's multiplied by, it will take the sign of something else. But if you want to keep it, you can. So that 2 is positive. 1.5 minus 1 is positive. It's a positive 0.5. And that will be squared. And 1.5 minus 3 is going to be negative. So that gives us a positive number squared will be a positive number. So we're going to get a positive number times a negative number. These two positives will give us a positive times a negative. These will give us a positive times a negative is a negative. And a positive times a negative is another negative. And two negatives cancel out to give us a positive. So that means on the upper portion of the graph, where x would be like 1.5, so about here, this part of the graph is going to be positive. So now let's analyze x equals 2.5. So 2.5 plus 2 squared, 2.5 minus 2, divided by 2 times 2.5 minus 1 squared, and 2.5 minus 3. So now we can analyze the signs on this one. So 2.5 plus 2 is positive. Positive number is squared. 2.5 minus 2 is still going to be positive. You have the positive 2. 2.5 minus 1 is still positive. 2.5 minus 3. Now that one is negative. A positive number squared gives us a positive number. Again, a positive number squared gives us a positive number. So two positives multiplied together is a positive. These two positives will be another positive, and then we'll have our negative. So we will have a positive number on top, and a positive times a negative is a negative. So we will only have one negative in this fraction, so therefore our entire answer is negative. So in this interval, it's going to be somewhere below, which means that our graph must look something like this, since we know it has to cross because the multiplicity is odd. Okay, so now I am going to have a look at something in here. I will have a look at 0.5. So we'll do this again when x equals 0.5. So if 0.5 plus 2 squared, 0.5 minus 2 is not squared, divided by 2 times 0.5 minus 1 squared, 0.5 minus 3. Okay, so 0.5 plus 2 will give us a positive number squared. 0.5 minus 2, that's definitely going to be negative. The 2 is positive. 0.5 minus 1 is, the 2 is positive. 0.5 minus 1 is definitely going to be negative, and it'll be squared. 0.5 minus 3 is definitely going to be negative also. So therefore, we will have a positive number squared is still positive. A negative number squared is a positive number. So we will have a negative number on top. And a positive times a positive is a positive. Times that negative is going to give us a negative. And remember, a negative on top and bottom will give us a positive. So that means when x is 0.5, we're going to be lying above the x-axis, which means that I'm going to assume that our graph is going to come down like this. And remember, it's going to touch here. And then it looks like it will stay underneath that asymptote. So there's one side. So let's see what it is at 5. So we are going to have 5 plus 2 squared, 5 minus 2. 2 times 5 minus 1 squared, 5 minus 3. Okay, and this one, since I have that horizontal asymptote, I am going to go ahead and evaluate it to see if it will cross that asymptote. All right, and notice it will not cross the x-axis. So whatever side it is on is the side it will stay on. It's going to be 7 squared times 3 divided by 2 times 4 squared times 2. And that's going to give us 7 times 7, that's 49 times 3 over 4 times 4 is 16 times 2 is 32 times 2 is 64. So that's going to be 49 times 3 divided by 64. And that is approximately 2.29. So it really doesn't look like it will cross at that point, and it is positive. So I'm going to say it will look something like this. All right, and of course, it's not always possible to necessarily get the graph maybe to look exactly right, because graphing these by hand is just notoriously difficult. So let me keep that graph in view. So our function is x plus 2 squared, x minus 2 over 2, x minus 1 squared, x minus 3. And it should look kind of something like this. Okay. A rational function. Now we can actually use a graph to write these also. So Yeah, and we will figure out how to do that. So let's zoom in a little on this. Okay. A rational function in factored form will have an x-intercept where each factor of the numerator is equal to 0. So that's the top. So where it crosses the x-axis, we will have a factor of x plus or minus whatever the number is. So looking at this graph, it looks like we have an x-intercept at -2, 0. And we also have one at 3, 0. So that means if we were to build some type of function, we would have, if x equals -2, then our factor is x plus 2. And that's because we just have to move it back over to be x plus 2 equals 0. So that means that if we have x equals 3, we're going to have x minus 3 as a factor. So now notice that these where they intersect the x-axis, they do not bounce off, they go through. So they will have an odd multiplicity. Also notice that they kind of resemble 1 over x. So I'm going to assume their multiplicity is 1. Now we will have to look at vertical asymptotes. So it looks like we will have a vertical asymptote at x equals -1 because it doesn't look like it's really going to cross. And it looks like we'll have another vertical asymptote at x equals 2. Now these are factors of the denominator that are equal to 0. So if we have a vertical asymptote at x equals -1, then we have the factor x plus 1 on the bottom. If we have a vertical asymptote at x equals 2, then that gives us the factor x minus 2. All right. So we have determined the factors of the numerator. And this is a good thing to look at. We have determined the factors of the numerator. Check. We have determined zeros and their multiplicity of these factors. We will determine the factor of the denominator, examine each side of the vertical asymptote, and that will help us determine the factors of their powers. So notice when we have x plus 1 and x minus 2, it does this odd parabola thing. Hold on. So one thing we're going to look at is which direction these graphs go on either side of the asymptote. So let me get a highlighter. Notice how this portion of the asymptote, they both go off in the same direction. So that would mean that that asymptote has a tendency to have a square on it. So that would be squared. Notice how these, at this asymptote, they go off in opposite directions. That would indicate that maybe there is a, maybe it is an odd multiplicity. So here we're going to stick with that. So we also have a y-intercept of this right here. So the y-intercept is going to be -2, 0. Now there is always a stretch factor, so there will always be an a that we will need to figure out in front of these. And I'm going to do that using this. So if my y is 0, or I'm sorry, it's switched. My x is 0, my y is negative 2. So if my y is negative 2 and my x is 0, I'm going to have 0 everywhere where x is. And I'm just going to keep simplifying and solve for a. So I'm going to get 2 times negative 3 divided by negative 2 squared is going to give me 4 times 1. So I am going to get negative 2 is equal to a times negative 6 over 4. And then I can just multiply by the reciprocal of the fraction to get it to the other side. So that's negative 4 over 6 equals a. Notice that these two negatives will cancel out and give me a positive. So I can go ahead and deal with that now. 2 times 4 is 8 over 6. And if we break all these down, 4 times 8 is 4 times 2. 6 is 3 times 2. And you can see that we can cancel these out. So our a is equal to 4/3. So we will have f of x equals 4/3 times x plus 2, x minus 3, over x minus 2 squared, x plus 1. It should be something along the lines of that. Let me zoom out a little. There we go. So this is writing rational functions. I would definitely recommend practicing this. I will go over it. So at least have a look at it. This can be a very difficult thing for a lot of people. So that was 3.7. Thank you, and I will see you in the next one.